Alex, is the Job Guide 360 interview guide worth it?
Honestly, yes, the guide is highly insightful. I recommend it to everyone.
Welcome to the deep dive. Today, we are really strapping in. We're looking at what's essentially a blueprint for, well, elite performance in a pretty demanding environment, the fast-paced tech startup.
That's right. And the source material we're diving into today, it's incredibly revealing, isn't it?
It really is.
It's this comprehensive stack of interview questions, the kind designed for high-impact front-end engineers.
Yeah.
So this isn't just theory we're talking about.
No, definitely not. It feels like a direct map of what these top companies actually prioritize, what they look for when they're seeking real engineering excellence.
Exactly.
So our mission today, it isn't just about prepping you, the listener, for some hypothetical questions. It's more like a shortcut.
A shortcut to understanding modern startup engineering.
We're extracting the formula, really. The technical judgment, the resilience needed, the business sense, all the things that define an engineer who genuinely moves the needle.
So where do we start? I think with that foundational test of ownership.
Right, the big one. How do you actually deliver a complex front-end feature, end-to-end? From the idea stage right through to production.
And what's immediately clear from the sources is, well, employers aren't just checking if you know React syntax, are they?
Not at all. They're looking for that holistic thinking, collaboration, real product ownership. It's like you need to treat the feature as if it's your own little business.
Precisely. And the core steps highlighted in the answers, they shift the focus completely. You start by clarifying the user problem.
Okay.
And defining those success metrics. You do that collaboratively, right, with PMs, designers.
Before you write any code.
Exactly.
Yeah.
Measurable outcomes first.
And then that critical strategic step comes next, proposing a minimal shippable slice. That feels like a huge shift away from sort of traditional big bang project management.
Oh, it's a massive shift. And it's all about risk mitigation, really.
How so?
You propose the absolute smallest version that gives real user value and, crucially, can be delivered quickly.
Okay, smallest version first. Why?
Because you build iteratively. And, importantly, behind a feature flag. That's the key.
Ah, the feature flag.
Yeah, it lets you deploy code that's maybe not quite finished, but safely. You gather quick feedback without blowing up the experience for your entire user base.
So the focus shifts. It's less about building some perfect monolithic thing up front.
Right. And
more about getting real validated data fast. That seems like it dramatically changes the risk profile of actually delivering something.
Absolutely. You deploy, you add only the essential tests and analytics you need right then for monitoring.
Just the essential.
Just the essentials. And then you track the results, the errors, post-launch. You use that real usage data to plan your next iteration, your next small step. That's the full life cycle of ownership in these high-velocity places.
Okay, so let's jump into the kind of technical judgment needed then, making those high-stakes architectural decisions, often, under pretty severe resource constraints.
Yeah, this is where it gets interesting. We're shifting from the what you build to the why you choose certain tools.
Exactly. Let's start with maybe the big one, state management. The great separation, as you might call it.
Right. This is critical because the landscape, it's changed so much, hasn't it?
It really has.
In a modern, complex app, how do you decide? React Context, Redux, ZooStand, maybe React Query? The quick answer used to be just use Redux, right?
Yeah, that was the default for a while.
But that's rarely the best advice now.
Right. The knock on Redux was always the boilerplate, the complexity. So what's the synthesized best practice now based on these sources?
Well, the consensus is pretty clear. You have to fundamentally separate your server cache, that's your data fetching results, basically, from your local UI state.
Okay, separate those two things.
Definitely. And you use specialized tools like React Query or SWR specifically for that server data.
Why those specifically?
Because they handle so much for you. Caching, automatic retries, background updates, data sync, it's all built in.
So that offloads a huge amount of complexity you'd otherwise have to build yourself.
It really does. Then, for the truly local UI state think, modal visibility, or maybe form input before it's submitted, you use lighter solutions.
Like Context or ZooStand.
Exactly. Context or ZooStand are great for that. You really only reserve Redux for situations where you genuinely need that robust, time-traveling dev tooling or maybe some extremely complex shared global state workflows.
Got it.
And just a word of caution.
Yeah.
Be really pragmatic with vanilla React Context. It's easy to accidentally create performance-killing re-render hotspots across your app if you're not careful.
So simplicity is the default principle here.
Always.
Okay, speaking of performance, Let's tackle the core Web Vitals rescue plan scenario. You've got a React app. It's agonizingly slow on first load, maybe janky when you scroll. What are the concrete, high-impact tactics to fix that?
Right. First things first, you absolutely must start with profiling.
No guessing.
No guessing. Use Lighthouse, Chrome DevTools, find the actual bottlenecks. Then you can target the big 3 metrics.
Let's quickly name those again for everyone. We're talking LCP.
Largest contentful paint, yeah. Measures perceived load speed.
CLS.
Cumulative layout shift, that's about visual stability, things jumping around.
NTBT.
Total blocking time, which measures how long the main thread is blocked, impacting interactivity.
Okay, so how do we fix them?
Well, for large, complex apps, route-level code splitting is pretty much non-negotiable. That directly tackles your slow initial load, your LCP.
Makes sense. Break it up.
Yep. You also need to serve optimized images, obviously. Use next-gen formats like WebP or AVIF, and defer loading any non-critical assets.
And what about the scroll jankiness? The TBT?
That's usually about reducing main thread work. So defer non-critical scripts, yes. But critically, if you're displaying long lists of data, think big tables, hundreds of rows.
Yeah, common problem.
You must implement list virtualization. You just have to.
Explain that quickly.
It means only rendering the items actually visible on the screen, plus maybe a small buffer. If the browser is trying to render, say, 500 list items that the user can't even see, you're just crippling the main thread. Virtualization solves that almost instantly.
Wow. Okay. Huge impact.
Massive. And the final step, always validate your improvements with real user monitoring, raw metrics, from actual users in production. Don't just rely on tests on your super fast dev machine.
Good point. Okay, let's shift to aesthetics and scalability. What about design systems? What's the philosophy on modern CSS architecture?
The consensus really favors a component-first approach now.
Meaning
Meaning whether you use CSS modules or maybe a modern CSS in JS library like style components or emotion, the key is having styles co-located with the component they affect. Clear ownership.
Makes sense.
And you leverage modern CSS grid, Flexbox, and increasingly container queries. They let you bake responsiveness right into the component level, not just the page level.
Now, building a full design system, that sounds like a big upfront investment, doesn't it? How do the sources justify that effort?
It pays off dramatically in velocity down the line. That's the key insight.
How so?
By defining design tokens, colors, spacing, fonts, ensuring accessibility is built in from the start. Building those standardized, accessible components, and using tools like Storybook to document and test them. One company actually noted they cut their new feature UI build time by roughly 30%.
30%, that's significant.
And they saw a measurable drop in accessibility bugs, too. It's proof that that upfront investment really does accelerate future delivery.
Okay, wrapping up architecture, rendering strategies,
Yep.
SSR, SSG, ISR versus CSR.
Yeah.
When do you pick which one? It seems complicated.
You know, it can seem that way, but the choice should be driven strictly by the business need, by the metric you're trying to hit.
Okay, give us the rule of thumb.
If the page is public, if it's content heavy, or if it needs strong SEO think marketing sites, blogs, product detail pages, you absolutely need server-side rendering, SSR, or static site generation, SSG. Maybe incremental static regeneration, ISR, for some cases.
Right, for search engines and initial load performance.
Exactly. But for your standard, run-of-the-mill, authenticated web application, where public indexing isn't a primary concern, you default to the simplest path.
Which is?
Client-side rendering, CSR. You avoid adding the complexity of a full-stack rendering framework unless the business specifically demands that SEO or first-load performance boost that SSR SSG provides. Don't overcomplicate your stack unnecessarily.
Okay, so we've designed for speed, for scalability, but, all that speed doesn't mean much if the whole system falls over the moment a user hits refresh or an API flakes out.
Exactly. Stability is paramount.
So let's shift our deep dive now to resilience. How do we actually ensure stability when we're shipping this fast? Maybe start with testing. How do you stay pragmatic under tight timelines?
Testing. This is where that engineering judgment really comes into play, isn't it?
Seems like it.
Because look, given tight deadlines, you simply can't write every single test imaginable. It's just not feasible. You need a focused testing pyramid, one that prioritizes high-value coverage.
That priority pyramid sounds great in theory, but let's be real, when you're sprinting, don't most developers either just write unit tests because they're fast, or maybe rely too heavily on slow end-to-end tests? How do you justify taking time for those heavier integration tests?
That's exactly the friction point, isn't it? And here's the core insight from the sources. Integration tests give you the biggest bang for your buck.
Why integration specifically?
Because they test the actual critical user journeys and, crucially, the API boundaries, the places where your front end genuinely interacts with the backend or third-party services. If an API breaks, if the data shape changes unexpectedly, a good integration test will catch it long before a user ever sees the problem.
Okay, so integration tests are like the insurance policy for the most critical and often most brittle parts of the application.
Precisely. Unit tests, absolutely necessary for complex business logic, algorithms, utility functions. But they shouldn't slow you down on simple presentational components. And those end-to-end tests, keep a very small set of them, just smoke tests, really. Reserve them only for your absolute revenue-critical flows. Take checkout, sign up, the core value proposition.
So a balanced strategy.
Exactly. It provides high confidence without letting testing become this debilitating barrier that prevents you from shipping.
Okay, next up, accessibility, A11Y. How do we make sure it's baked in from the start, not just, patched on as an afterthought?
It absolutely has to start at the root.
Okay.
Semantic HTML. Just using native elements correctly gets you so far.
Use the platform.
Use the platform. And you must ensure keyboard navigability and proper focus management are default behaviors for every single interactive element. That's non-negotiable.
What about ARIA attributes? People seem to reach for those a lot.
That's the key insight here.
Yeah.
Use ARIA sparingly. Only reach for it when native HTML genuinely doesn't provide the necessary semantic context for assistive technologies.
Yeah.
Don't sprinkle it everywhere just because you can.
Less is more.
Less is definitely more with ARI. Then you integrate automated checks, like the Axcore tool, right into your CI/CD pipeline. And finally, perform basic screen reader smoke tests on your key user flows. Just listen to it. Does it make sense?
Practical steps. I like it. Now, let's face reality. We often have to work with messy, maybe unreliable data sources. How do we build resilience when we're integrating with, say, unstable third-party REST APIs that might just fail randomly?
Yeah, that's a common headache. Resilience and transparency are key here.
Okay.
When you're wrapping those potentially flaky API calls, you absolutely need retries with exponential backoff.
Yeah.
Don't just hammer the API immediately after it fails once. Give it space.
Makes sense. What else?
Cache successful responses aggressively wherever data staleness is acceptable. If the data doesn't change every second, cache it. And in the UI, use skeleton loaders or placeholders during that initial load to prevent layout shifts and content jumping around while you wait for the data.
That improves the perceived performance too. What about user actions? Can we make the application feel faster even if the network is slow?
Yes, absolutely. Through optimistic updates.
Explain that.
For safe user actions, think clicking a like button, maybe adding an item to a temporary list. You update the UI immediately, pretending the action succeeded, before the network call even returns.
Sounds risky.
It can be, which is why you crucially must implement a clear rollback mechanism. If that API request ultimately fails, you have to revert the UI change and inform the user.
Got it. Rollback is key.
Absolutely. And alongside this, you need excellent client-side error logging and alerting so you can quickly identify and escalate issues with those third-party vendors when they do fail repeatedly.
What about the extreme case? Going fully offline. Let's say we needed limited offline support for just one core workflow. How complex does that get?
It definitely adds complexity, no doubt. For limited critical workflows, you first identify the absolute minimum data needed for that workflow to function offline.
Okay, minimal data set.
Then you cache that data persistently, usually using IndexedDB, often managed via a service worker.
The service worker comes into play.
Right. The service worker then acts as a proxy, handling the fetch requests, serving cached data when offline, and fetching from the network when online.
What happens if the user changes data while they're offline?
That's the tricky part. You have to queue those mutations locally, store the change the user made.
Okay, but then what happens when they reconnect? That sounds like a potential minefield, right? What if they changed something locally, but someone else changed the same thing on the server in the meantime?
Yep, welcome to conflict resolution. In a fast-moving startup, you typically don't build a super complex Git-style merge tool for this. It's overkill.
So what's the pragmatic approach?
Usually you default to a simple strategy. Maybe last write wins. The user's local change overrides the server version, but you notify them. Or maybe you prevent the local change from syncing until they manually confirm the server data hasn't diverged too much.
So clear communication with the user is vital.
Absolutely critical. The UI must clearly, visibly, but non-intrusively indicate the current offline state and the sync status. Users need to know what's going on.
Okay, let's talk security. This is obviously non-negotiable. What are the key front-end security defenses we need to have baked in?
The list is pretty clear and consistent across the sources. First, foundationally, treat all user input as untrusted. Always.
Assume it's malicious.
Assume the worst. Rely on your framework's built-in escaping mechanisms to prevent cross-site scripting, XSS. Don't try to roll your own escaping.
Okay.
Use secure HTTP headers. Set same-site attributes on your cookies appropriately. Implement anti-CSRF tokens for state-changing requests. And the most basic rule, often forgotten,
What's that?
keep all secrets, API keys, sensitive tokens out of your client-side JavaScript bundle. They don't belong there. Ever.
Right. Server-side only or environment variables during build.
Exactly. And finally, implement strong content security policy, CSP headers, ideally using nonces or hashes, to explicitly whitelist which sources of scripts, styles, and other resources are allowed to load.
Okay, great. So we've built this robust, secure, performant product. We ship it. Job done.
Not quite. The job isn't done post-shipping. Monitoring is crucial.
What should we be monitoring specifically on the client side?
You absolutely need to instrument real user monitoring, or REM. Track your core web vitals and general page load latency out there in the wild, with real users on real devices and networks.
Right.
Use an error tracking service, and make sure you upload source maps so you can actually debug the minified exceptions you get. Otherwise, those errors are useless.
Good point. Source maps are key.
Definitely.
Yeah.
And beyond just errors and performance, you must define dashboards for your key business funnels. Sign-up flow, conversion paths, critical feature usage, track the drop-offs.
Connecting it back to the business.
Always. And set sensible alerts. Avoid alert fatigue. Only page someone or trigger an alert for issues that are clearly actionable and are demonstrably negatively impacting those core business metrics or the user experience.
Okay, we've covered a ton of technical ground, but being a top engineer in a startup, it's more than just code, isn't it? You also need to be something of a business owner.
That's a great way to put it, yeah.
You often have to wear multiple hats, right? Jumping between front-end work, maybe some light design tweaks, maybe even fixing a broken build pipeline. How do you manage that context switching without completely derailing your main delivery goals?
The approach has to be laser-focused on unblocking immediate delivery. That's the startup way.
Okay.
You absolutely need to be comfortable stepping outside your strict front-end comfort zone. But, and this is key, you have to be disciplined about it.
Disciplined how?
Time box your research heavily. If you're diving into something unfamiliar, give yourself a strict limit. If you're fixing, say, that build pipeline, default to the simplest viable fix. The Band-Aid solution, maybe?
Get working first.
Get it working, unblock the team now, but immediately document the quick trade-off you made and propose a proper, deeper solution as a follow-up task. You prioritize unblocking velocity today, not achieving perfection today.
This kind of environment, it often breeds conflicting priorities, doesn't it? How do you handle that classic scenario where, say, the product manager wants feature A, but the founder is pushing hard for feature B and they're pulling you in different directions?
Oh yeah, that happens. The absolute worst thing you can do is pick a side based on who shouts loudest, or seniority, or just gut feeling.
So what do you do?
This is stakeholder management, driven by data. First step, clarify the underlying goal and the deadline for each conflicting request. What are they really trying to achieve?
Understand the why behind the what.
Exactly. Then you outline the estimated impact, the potential risks, and the engineering effort required for each option. Put it down in a neutral, shared document.
So you present the options objectively, not just your personal preference.
Precisely. Then you escalate, if necessary, with a clear recommendation. And crucially, that recommendation needs to be explicitly tied back to the overriding company metrics. Which option delivers the most measurable value or mitigates the most risk for the least effort right now?
Data-driven decision.
That's the goal. And you document that final decision clearly so everyone is aligned and understands the rationale. It prevents team thrash and keeps everyone focused on outcomes, not opinions.
What about culture building? In these small, fast teams, what defines a successful culture? One that's fast, but not just chaotic.
It really boils down to cultivating psychological safety and efficiency.
Okay.
You need to actively promote a culture of clear ownership. People need to know what they're responsible for. Fast feedback is also essential, especially in things like code reviews keep them moving.
No bottlenecks.
Right. Critically, foster blameless learning. When things inevitably break, and they will, the focus needs to be on understanding what happened and how to prevent it, not who to blame.
That builds trust.
Huge trust builder. And keep your process rituals lightweight. Short, focused RFCs, requests for comments, for significant architectural decisions, frequent informal demos of work in progress, pragmatic, outcome-focused code reviews. This lightweight documentation is key. It prevents critical decisions and context from being trapped solely in people's heads when the team grows or changes.
Okay, let's bring it home with maybe the most crucial step for any high-impact engineer, especially in a startup. Connecting your code to actual business outcomes. How do you quantify your results and really prove your value?
You absolutely must translate the engineering work you do directly into tangible business results. It's the difference maker.
Got example.
Yeah, the source material had a perfect one. An engineer leads a performance optimization, project image optimization, route splitting, the stuff we talked about.
Okay.
The result wasn't just the site feels faster. The result was LCP improved by 38%. And user conversion increased by 9% month over month.
Wow. A sustained 9% lift in conversion. That's huge. That work didn't just improve UX, it literally paid for itself, likely very quickly, by generating more revenue.
That right there, that is the definition of a high-impact engineer.
Clear connection.
Crystal clear.
Yeah.
Another great example given was about 0 to 1 ownership, maybe launching a brand new onboarding flow.
Okay.
The process was align stakeholders with a concise RFC outlining goals and scope. Deliver it iteratively, behind a feature flag, of course. Run an A/B test comparing the old and new flows. Instrument the funnel metrics meticulously.
And the outcome?
The outcome was quantifiable. The new flow improved user activation by 18% and measurably cut related customer support tickets. That impact, the measurable improvement on a key business metric, that's the ultimate measure of success.
That really brings us full circle, doesn't it? This whole deep dive, it seems to show that real front-end expertise in a startup, it's maybe less about knowing every single syntax detail or the latest library version, and far more about applied judgment, building resilient systems, and having this laser focus on business alignment. The expectation isn't just coder, it's owner.
Exactly. An owner who can confidently quantify the impact of their work.
Yeah.
And the true test of an engineer's judgment, I think, often isn't knowing the definition of every tool out there. Redux, React Query, Zoostand, whatever's next.
What is it then?
It's deciding which tool to not use.
Yeah.
It's choosing simplicity and knowing how to justify that choice because it accelerates delivery or reduces future complexity and maintenance burden.
That is a phenomenal takeaway. Choosing what not to do is just as important. Okay, so here's a final provocative thought for you, our listener, to chew on. When you think about those measurable impacts we shared today, that 38% LCP improvement, the 9% conversion gain, the 18% activation lift, what metric would you target next in your current role right now to really prove your value? What's the next piece of work you could do that would demonstrably pay for itself? Something to think about.
Definitely food for thought. Thanks for diving in with us today.
Yeah, great discussion. We'll catch you on the next deep dive.